Okay.
So chapter 8 will deal about the system response. What is the meaning of system response? See, when you are going to give some input to the system will respond based on its components, and then after that it will give the required output. You know? So the what? New medicine. If you are finding the new medicine, you are giving the new medicine to the rat to find the response from the rat, and then after that we are giving the medicine to human being. Same like that, before you are going to install one product or system in the application place, you are checking the system by giving some input. So there are different kind of input that is called test signal. To inspect the system, we are having some test signals. So there are different kind of test signals. Some important test signals are given here. Step input, ramp input, sinusoidal input, impulse input. So we can give this kind of input to the system, any one of the system if you have developed, and then after that you are going to find the response from the system. That means performance of the system. Okay. If the response of the system, if it is going beyond the limit or if any error is coming, then you are finding, before it is going to implement in the application area, you are finding, when you are inspecting the system, you are finding the error, and then after that you are eliminating the error. Again you are giving the test signal, and then after that you are checking the response of the system. If the system is giving the perfect output or required output, then after that only you are releasing as a new product. Okay. See, for that purpose, this system, see, to control the system, these are all very important to control the system. If any error is coming, you have to control the system. How can you find the error? If you are giving some input voluntarily, and then after that you are finding the system response, then you are checking how the system is responding for that particular test signal, and then after that you are, if any error is coming, you are rectifying, or otherwise you can find after a certain period of time what will be the system, what will be the system response, all those things. See, after 5 seconds the system how it will be, after 10 seconds how it will be, all those things you can find by giving some signals. So there are different kind of step input, different kind of input, step input, ramp input, sinusoidal input, impulse input. The step input, what is the meaning of step input? See that. Suddenly you are giving, this is like a constant. So the constant, see, 5 volt you are giving to the system, or 10 volt you are giving to the system, or 240 volt constantly you are giving to the system. So you are giving the system, you are giving an input to the system constantly, and then after that you are finding the response of the system. So that kind of output it is called as step input. Just one step, that means constant, and then after that you are maintaining. See, R of t equal to x, x means this much. R of t equal to x, say for greater than t equal to 0, this is x. For greater than t equal to 0, if t less than 0, R of t equal to 0. The ramp input means it is constantly increasing based on the time. See, the linear relations between the amplitude and time. So if you are giving, first second you are giving some 5 volt, and then after that 10 volt, after that 15 volt, after that 20 volt. Like that, you are increasing based on that time, and then after that you are finding the response of the system. Then these kind of inputs are called as ramp input. Sinusoidal input means alternating. It's like alternating current, AC current, no? AC current is like the positive and negative you are giving. See that is some phase difference is there. Then t second it is going positively, and then after that next second, next time it is coming to the negative, and then after that again it is going to the positive. So all those things you are giving, and then after that you are finding the response of the system. This kind of input is called sinusoidal input. Then impulse input means sudden input. You are giving input immediately, and then after that you are withdrawing that. See that for particulars, it's coming always its accidents to 0. See that suddenly you are giving input, and then after that you are not giving. So this is used to find the impact. Okay. So suppose you are giving impact signal. Suddenly, see in a system, if it is running, suddenly the power is increasing, and then after that it is coming to the 0. If suddenly increasing means how the system will respond. So for that purpose we are giving the impulse input. So these are all the test signals. The response of the system. So we are having in the syllabus first order system second order system. The response of the first order system, first we will see. See, this is one system. This contains one dashpot and one spring. See, the equation of this equal to C equal to dy by dt plus ky equal to kx. So this one we dealt already in the chapter 7. Correct? In chapter 7, in the modeling, we discussed this. So how this equation is coming, you know very well. So this system, see that k is the constant. If you divide the whole equation by k, it will come like c by k into dy by dt plus y equal to x. This is looking like a first order equation. See that the order of the differentiation is 1. That's why this is called as first order equation. The title is response of the first order equation. So you have to take one first order equation, and then after that you have to give any one of the test signal to find the response of the system. Correct? So this is the method to find the response of the system. In a mathematical way, how to do the response of the system? You have to take one system. It may be a first order system, it may be a second order system, it may be a third order system. Any one system you have to take. Here I am taking the first order system. See that? This is one first order system. The general equation of the first order system is tau into dy by dt plus y equal to x. This is the generic equation, general equation of the first order system. You are going to give one test signal, any one of the test signal. You assume the first we are giving the step input, you assume. So step input we are going to give in this system, and then after that we are going to find what will be the response of the system. You are going to plot a graph. We are going to plot a graph against the time. For 1 second, what will be the output? For 2 seconds, what will be the output? For 3 seconds, what will be the output? Or for 0.1 second, what will be the output? If you are plotting like that, that is called response graph of the system. Okay, how to do that? The first you have to take the first order system, and then after that you have to take any one of the input system. This input you are giving here. See, this is the input here. Here you are giving input, and then after that you are going to find what will be the response equation. So to solve this equation, we should know the Laplace transform formulas. Why we are using the Laplace transform? If you convert one differential equation into Laplace transform, it is very easy to solve one differential equation using the Laplace transform. So once you have to convert to Laplace transform, then after that again you are converting into the t with respect to t equation. So then you will get the response equation in terms of t with respect to t. See, the response equation means you are taking one first order system, you are taking one step input system. You are converting the first order system and step input into Laplace transform, equivalent Laplace transform. And then after that you are solving the equation using the Laplace transform. End of that, again you are converting the Laplace transform into t domain using the inverse Laplace transform technique. And then after that, after finding the response equation, then you are substituting t equal to some 0.1 second, 0.2 second, or 1 second, 2 second, 3 second, like that. And then after that you are finding what will be the response of the system, then you are plotting the response graph. So this is the procedure in finding the response of the system. See that here you have taken one first order system, general first order system equation. I have taken tau into dy by dt plus y equal to x. Then there are some Laplace transform formula. Y means convert into Laplace transform means y of s. Dy by dt means s into y of s. D square y by dt square means s square into y of s. Constant means k by s. Okay. These are all some Laplace transform formulas. Okay. You should memorize this. No other. So you are taking the first order equation. See that I am going to take the first order equation. The tau into dy by dt plus y equal to x. Okay. See, if you want to convert the tau into dy by dt plus y equal to x means, see, the first one, the general equation of first order system, tau into dy by dt plus y equal to x. dy by dt I have given. Dy by dt means what is the Laplace transform? S into y of s. So you have to give here s into y of s plus y means what? Y means y of s plus y means y of s equal to x means x of s. X means x of s. Okay. So I am going to take y of s outside. Y of s outside. What will come? Tau s plus 1 equal to x of s. Then y of s, this is the output. Y of s equal to x of s divided by tau s plus 1. Okay. This x of s, what is the meaning of x of s? It is input. What is the meaning of y of s? Y of s is the output. The input, you assume I am going to give step input. X of s, I am going to take it as step input. Assume step input I am going to. The step input means it is a constant input. Constant means you assume k. The k means if you want to convert the k into Laplace transform, what will come? K by, you see that? Constant means k by s. Then again I am going to assume, I don't know k. So that's what I am going to assume unit step input. Unit step input means k equal to 1. Unit step input. K equal to 1. If I am going to put k equal to 1 in the previous equation, then 1 by s will come. So 1 by s if I am giving here, then what will be the response equation I have to find? See that y of s equal to, instead of x of s is the input. X of s equal to input. So that's why I am going to give 1 by s, then tau s plus 1. So this one mathematically the 1 by s, this s will come and the new denominator. So 1 divided by s into tau s plus 1. Okay? 1 divided by s into tau s plus 1. So there are certain formulas to convert. This is, now I have converted into, I have found the equation using the Laplace transform. Now I have found using the Laplace transform. Now I am going to convert this Laplace transform into inverse Laplace transform to find the equation in t domain, because this is given in t domain only, dy by dt. This is not in t domain, not in t with respect to t, it is with respect to s it is there. So now I am going to convert this equation into t domain. So for that some formula is available. One of the formula is a divided by s into s plus a means 1 minus e power minus a. This is the formula. This is the formula to convert a Laplace transform into inverse Laplace transform. Okay. Using the inverse Laplace transform, you can convert the s domain into t domain. A by s into s plus a equal to 1 minus e power minus a. So there is a a, see that instead of this here, inside the parenthesis, s plus a is there. Here tau s plus 1 is there. The a if you consider 1, but the tau extra is there. Tau means it is a time constant. The time constant extra is there, that's why you have to take the time constant outside. So if you are taking the time constant outside, 1 by tau s into s plus 1 by tau. If you take one constant from this term, you have to divide the whole equation by that term. Okay? So that's what I have divided 1 by tau. So this one I am going to write in a different way. 1 by tau divided by s into s plus 1 by tau. You compare this equation, a by s into s plus a, 1 by tau into s into s plus 1 by tau, a equal to what here? A equal to what here? 1 by tau. A equal to 1 by tau. So this meaning is a by s into s plus a means 1 minus e power minus a2. So based on that formula you convert 1 minus e power minus, instead of a what is there? 1 by tau is there. So you put 1 by tau, then after that t. So this is the conversion of s domain into t domain. So s domain into t domain, if I convert, the equation is coming as 1 minus e power minus 1 by tau into t. So now again you assume the time constant, I don't know how much. So that's why I am assuming, see, the equation is coming y of t, not y of s. Earlier y of s, now y of t equal to 1 minus e power minus 1 by tau into t. I don't know tau, so again I am assuming tau equal to 1 unit. Okay, then the equation will become y of t equal to 1 minus e power minus t. This is the equation for first order system with respect to unit step input. Okay, this is the response equation. This is called response equation. Response equation of the first order system with respect to unit step input. Now I am going to give, see the response table I have to find. What is the need of response table? I am going to find the response of the system for various time. That means I am going to give t equal to 0.1, 0.2 or 1, 2, 3 like that, and then after that I am going to find what will be the output will be. Okay, output. See that the t value, already we did this problem, the t value y of t equal to 1 minus e power minus t. If I am giving the t value 0, it is coming as 0. If I am giving the t value 0.5, it is coming 0.39. If I am giving 1, it is coming 0.63. If I am giving 2, 0.86 is coming. If I am giving the 3, 0.95 is coming. If I am giving 4, 0.99 is coming. 8 is coming. 5 means 0.99. Then it will be this is the maximum it is achieved. 0.3, 0.99, 99% it is achieved. And then if you give 6, 7, 8, then again 0.99, 0.99, only will come. This is called the response table. How to draw the response curve? Response curve using the graph. Response curve. You have to take the t in x-axis, and then after that you have to take y of t in y-axis. The y of t is given, so you give a 0, 0.1, 0.2, 0.3, like that up to 0.9 you are up to 1 you are giving. Here you are giving 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5 like that. Then 0.5 means you are going to mark here 0.39, the 0 means 0, and then after that if you are giving the 2 seconds, it is coming as 0.86, and then if you are giving 3 seconds, it is coming as 0.95, then if you are giving 4 seconds, it is coming as 0.98, and then after that if you are joining all together, you will get response curve of the first order system. Response curve of the first order system, for which one? For unit step input. Unit, not step input, unit step input. So what will be the procedure? See here, once again I am explaining. You have to take the general first order system, and then after that you have to assume we are giving the unit step input. Okay. The first you are converting this general first order system into Laplace equation. This is coming as y of s equal to x of s divided by tau s plus 1, and then after that you are giving step input. The step input also you are converting into Laplace transform, which is coming 1 by s. Instead of x of s you are giving 1 by s, so the equation will become 1 by s divided by tau s plus 1. And then after that you are doing some mathematical, okay? Some mathematical magic you are doing, okay? And then after that you are bringing like a by s into s plus u. Because we are having formula a by s into s plus a means, that is in Laplace transform. If we are converting from Laplace to Laplace inverse, then 1 minus e power minus at will come. So this formula we are having. So because of this reason, what term we are having, that you are converting equivalent to this formula. And then after converting that, you will get 1 minus e power minus 1 by tau into t. Again, the tau is the time constant. Again, I am assuming time constant equal to 1. And then after that, y of t will come 1 minus e power minus 8. Okay? So this is called response equation. In the response equation, you are giving the different timing, and then after that, you are finding what will be the response of the system. Then you are tabulating. This is called response table. And then from the response table, you are taking the graph, and you are taking x-axis t value, you are taking y-axis the amplitude value, that is response of the system. And then after that, if you are plotting, you will get response curve for the first order system. Any doubt in this regard? No doubt. So now I am going for the second order. Now I am going for the second order system.